Kubernetes está hecho de hecho estuve dando caña durante la temporada y yo pasé en eso, pasé todo, está todo el día una empresa de una búsqueda de investigación, tienes que poner ahí, o sea, eso es intentar una
Yeah, we have a few more minutes. Yeah, 10 more minutes. So much more action. Yeah, there's one more. Yes, live stream. No. That you can rewatch the live stream, I think. Yeah, except that the first bit wasn't streamed because there were some issues. Maybe not very handy to find it, but it should, if you look at the config management account, it should be one of the videos. And just look for the one that ended a few hours ago. I think at the beginning doesn't have sound or something, there's some glitches here and there.
Hello, so welcome at day 2 of the Kubernetes community room. The first talk of this afternoon will be given by Alexander. Alexander is a sysadmin at the Linköping University in Sweden. I had the pleasure of joining in during the speakers dinner. And the nice thing about Alexander is that he has a lot of fun facts. For example, he told me there's an ISO standard for brewing a cup of black tea. And I was really, I thought this was really funny. Alexander will be talking about bare metal deployments on of Kubernetes, so go ahead.
Right, so to begin with, yeah. Hopefully people here are familiar with what Kubernetes is. Maybe you've used it before. Because I realized later on that I haven't actually written any slides for the people who don't know what Kubernetes is, so... But yeah, should we find something? Yeah. And yeah, I've planned a few live demos, so yeah, if I'm gonna expedite that process by taking your questions, so like, yeah. Okay. So good? Yeah. Okay. Yeah, so I'm here to ask and answer one simple question. Tools for automatic Kubernetes cluster setup and management. Why not Bucket? Yeah, so I'm a sysadmin at Linköping University, been employed there for 2 years now. I get to spend more time doing it close to DevOps running the sysad. Okay with that. Spent 12 years programming before. And you can find me on Mail, you can find me on many different types of IAM. Most of my stuff's on GitHub. You might find references to my old GitHub account. In that case, it needs to be updated, but such a thing. And yeah, just to be clear, my favorite beer choice is the very dark stouts. Also, a bit partial to the Belgian. Okay. So yeah, before beginning, it's a disclaimer, guys. There are many tools for manually deploying Kubernetes, especially if you're doing like cloud setup on a GCE or AWS, Azure, lots of tools for that. And I mean, like Kubad and Kubespray, there's a tool just simply called the easier way. I haven't actually used them. I run all of my Kubernetes clusters on bare metal. I mean, I think there are a handful of rules. I don't think it's Salt actually called the Salt stack. Yeah. You can do like raw RPM installs on CentOS as well. Yeah, Puppet is probably a bit more advanced, more complicated than most of the other ways, but it's also fully automated. I don't have to do any manual work to do the whole cluster setup and stuff. So, just a little bit about Puppet itself. It's made by Puppet Labs. There's a few of their logos, both the old ones and the new ones. Anyone here who knows what Puppet is? Use it, maybe? A few of you? Yeah, so that's what Puppet can look like, but yeah, it's Puppet will give you like a configuration management, which is what you want, really. And you can reuse your configuration modules through the Puppet Forge. Quick disclaimer, this isn't on the Puppet Forge yet, sorry about that. We'll get out soon, hopefully. But you get some system inventory with Puppet DB, you can do automated task deployment using Puppet Vault. There's some orchestration support with M-collected Fourier, which I'm actually going to use during this talk, but you don't need to. So, which is the part you actually need to do a Kubernetes cluster with this is, well, you need a Puppet master. You need to have it connected to a Puppet DB. And you need to have one or more nodes that are registered with it. Or a tool to let you provision the new ones, like Foreman. And yeah, the module itself doesn't need a Puppet master, it doesn't need a Puppet DB. You can just do Puppet apply with the raw manifest. It'll work, but you'll probably not be able to do it fully automatically. But yeah. And the code I'm not actually going to show you any code at the talk, I'm just going to show you effects, but the code that I link at the end is dependent on having a master and the Puppet DB linked up. But yeah, we're going to start with a quick demo. So we can actually we can start here. Yeah. We got a cluster running here. It's got a few nodes in it. But yeah, we want a few more. So we can just go in here, and I actually pre-prepared a few nodes here. They're installed with just bare CentOS, no Kubernetes pieces at all, but I'm gonna say that these should be Kubernetes. Because we like Kubernetes in this room here. So that's actually gonna launch something in the background real quick. There we go. And yeah, so basically what's going on right now? I moved the host to a new host group and did some behind the scenes magic. Magic is happening. Yeah, so basically the formal lifecycle management tool, which is in this case used as the Puppet external node classifier, has reclassified these nodes as having the classes for my Kubernetes deployment on them, which was through a host group that collected the classes and assigned parameters for the cluster is supposed to join and all that necessary information. And then I actually launched an M-collected run that is orchestrating Puppet runs on all the affected nodes. So it's going to run Puppet on the new nodes themselves, which will set up the Kubernetes binaries, launch all the services, create all the configuration files. And since we're using the Puppet CA as a core CA here, we're not going to bother with certificates. We already got node certificates. Yeah, we already got node certificates through the Puppet CA, so we're just going to reuse those. And yeah, regularly Puppet runs every 30 minutes or depending on what your configuration is, but to make this talk fit inside the schedule, I'm just going to orchestrate all the Puppet runs that would normally be spread out over several hours. And you can speed this up by running several shorter Puppet intervals or orchestrating the Puppet run when required. And yeah, so there's some magic behind the scenes here. So I've written a module for Puppet, and since Puppet uses a global namespace, the name is a bit important. And I happen to know that there are more than one module named Hypercube, or more than one module named Kubernetes. It's like the Puppet Labs Kubernetes module, which will set up Kubernetes for you on top of GCE, I think. I haven't actually looked that partly at it, but yeah. But yeah, it's and there's one module that I was planning to use for this. It's called by Gareth R. And it's actually lets Puppet orchestrate Kubernetes results directly into the cluster, so you can you can Puppet manage your actual objects in Kubernetes as well. But in order to not collide with all of those, I decided to name mine Hypercube, since I'm using the Hypercube binary for everything. And yeah, currently I've already set up etcd before. There are ways to do that. I actually, in the code that I'm going to link later on, there is the files necessary to set up a fully automated and fully scaling SD cluster. Flanell, I have started doing Flanell. It's not finished yet, so these nodes are running Flanell from the RPM packages that are available in the, I think, EPO for RHEL 7. And these are also using firewall-D, so I'm setting up firewall rules for them. This is, yeah, pre-prepared the nodes a bit. They already have all the libraries in place, so the pub run shouldn't take that long. And yeah, normally I would have, like I said, normally I would have provisioned the nodes completely from scratch, but that can take upwards of half an hour just to get a single node running. And we don't really want that. That's going to be painful. But yeah, let's try a second demo. Let's see what's happened here. There we go, 2 new nodes, 2 minutes ago. And they're sitting here running Kubernetes 186. It's not the latest one. I mean, it's nice, but it's not the latest. So, you know what? Let's do the latest one. What could possibly go wrong? So, there's gonna be probably a bit more. I can't monitor the okay, you know, actually I'm gonna write on my screen. Drop it over there later. So I'm just going to set them to Kubernetes, to run Kubernetes 192, because I like 192. It's a nice version. It's what I run on my other clusters. And then just to start off here, I'm going to have actually one of the nodes. I'm going to start the run on that. I'll show you live what's going to happen, and in the meantime, I'm also going to orchestrate a run on the other ones. So I'm currently running Puppet on one of my nodes, which, yeah, I'm damn like I can't launch a Puppet run on it because it's currently applying a catalog. And the other nodes are also now running Puppet, and they're going to, hopefully, they're going to download a new Kubernetes binary. They're going to remove the old one, going to redo all my service files, they're going to update the configuration, and they're going to restart all the services. And I did this at the production cluster at work. I did this by setting the version number and going on launch and returning to a brand new 192 cluster. So let's see how it goes actually. I haven't timed this before, so I'm not quite sure exactly how long it's going to take to run the whole upgrade. Hopefully less than a few minutes, but hard to time that. There we go. Now I've got a 192 binary in place. The old files have already been removed. Configuration is updated. Systemctl does the daemon reload. The services are refreshing. I think that should be about time. So actually, let's drop back into the cluster, see what we've got. And one node has switched, yeah, because that was one I launched earlier. The other ones. So the other ones are going to slowly but surely drop by and upgrade themselves. And the master server as well is currently running 192. Or no, it's not. It's not updated yet. Oh well, it's probably gonna take a bit longer than the other one since it has a few more services that it needs to restart in order to actually apply the upgrade. The other ones just need to restart the kubelet and the kubeproxy services to get them running. And I'm working on getting that into the Dockerized state, so the containerized state, so you can run the proxy, so that the module will set up for you a kubeproxy running inside of Kubernetes itself, but that's not at the moment done. There we go. Now the cluster is completely 192, I think. Yeah, 100% 192 cluster, which I think is pretty good considering it was 187 and it lagged 2 nodes when I started this talk 5 minutes ago, or so. 10 minutes ago, actually. But yeah, the module, it can be user brushed. And yeah, it's not on the ForgeForge yet. It's not it's technically not a technical issue. It's some bureaucracy involved. We have to actually set up an official account, and I'm not quite sure about the license if they will let me use MIT if I need to switch to GPL. So I'm gonna try to get it out of the Forge, but it's already available through GitHub if you feel like running it direct from Git. But there's a production branch. I can promise not to do any strict or like big changes without at least notifying it first. And yeah, it's currently cheating a bit. I'm deploying YAML blobs and using the Kubernetes add-on manager to reconcile them over time. I want to switch to using the Gareth R Kubernetes module, which will let me do orchestration with Puppet to orchestrate the resources directly into place. And I'm still lacking a few good to have add-ons. I don't have the Kubernetes the container network interface stuff is not fully automated at the moment. You can deploy it, but at the moment that requires you to do staging and deploy, where you download a archive and extract the necessary files. It's lacking a few Docker packaging places, so it's you can't run it inside itself at the moment. It's not. It can't do a self-hosted Kubernetes cluster. It uses native binaries in an opt folder at the moment, which it works. It's not going to collide with any other applications, but it would be nice to do a fully self-hosted one. And it's also something I'm going to work towards in the future. Currently, also the whole modules for actually linking it together into a fully automated system is currently written against the old Puppet DB query module instead of the more modern Puppet PQL query system, since that didn't exist when I started this, which I'm also planning on upgrading since it's new, it's cool, it's official. And actually I talked to the Puppet guys lately, so there's recently to yesterday and to today, there are a couple of RVs up for doing better support for using the Puppet search. So if you want to actually have a single CA in your network, you have to do some manual work. There is actually a code link for that as well, how to do a Kubernetes master API cert with the Puppet CA and still be able to use it for Kubernetes without getting lots of TLS validation errors. There's no support at the moment for doing Puppet certificates, like using the Puppet certificate for the actual nodes, since Puppet certs only allow you to set the common name, not organizational names, which you need for the Kubernetes group membership. But there are RFPs open for this. Hopefully they'll be resolved soon. But I mean, if you're not planning on using the Puppet CA for all your certificate needs, you can still just use the Bootstrap tokens and use the Kubernetes CA without issue with this system as well. I don't have any examples for that at the moment, since all the systems I'm using are using the Puppet CA, but shouldn't be too hard to do if you've already set up a Kubernetes cluster with the Bootstrap token system. And of course, I accept pull requests for all of this. The documentation for how to set it up are currently spread in a couple of separate guests, but they can be merged into the repo itself once if people want a more official looking documentation for them. But yeah, you have a link to the code itself. There's I've got lots of other projects on my GitHub. I'm available in many different places. If you recognize the IAM names, you can just send me a message. I'll try to respond as best I can. Throw me a mail. I mean, throw a pull request. I'll be happy to review and what changes you want to do. But yeah, there are any questions about what you just witnessed? Yeah.
When upgrading between versions, do you not want to do a more controlled sort of rolling restart? What would have happened to your actual pods during that time?
Yeah, usually Puppet doesn't Puppet has a built-in splay system where not all the nodes run Puppet at the same time. In this example, just to get things to go quickly, I orchestrated a Puppet run across the entire cluster at once. Normally you wouldn't do this. So you get the rolling upgrade just by the fact that all the nodes are running spread out over a half-hour window. And since it takes less than a minute to do a full upgrade of a node, you don't notice it. Oh yeah, and the question was, of course, if it would be an issue, like if you shouldn't do like rolling upgrades instead of replacing the entire cluster version at once. Any other questions?
Are you doing a etcd upgrade during instead of, for example, cluster upgrade, or etcd upgrade is not considered? This is more
Please repeat the question.
etcd.
It's
cluster upgrade.
etcd cluster upgrades are a bit more difficult, but usually, like the switch from etcd 2 to etcd 3 is not automatable as far as I know. Doing a etcd cluster upgrade itself should be just, in the case of the RPM package, just install the new RPMs and restart the services. Yeah, anything else? Yeah.
Are you sure it's not automatable?
What?
Are you sure you can't automate the TCD2 to TCD3 migration?
Yeah, it probably could, but I don't know if you want to, considering it's prone to errors. At least when you did the first upgrades on etcd 3.0, there was a few issues you could run into, and I had to redo the migration, I think 3 or 4 times before I got it to stick. You should be able to automate it with the modern versions, yeah. Anything else? I could say it's an issue.
So they want to be in there. They couldn't. So they give you but I don't know how it so you can get a copy of the document for specification. Yeah, that's from this is exactly the case. Yeah.
So, sharing and distributing.
She got a room.
So it's in one line, so it's very if people it's another room.
Yeah, she got a room.
That sounds like a
Yeah. And it comes every 1 hour.
Yeah, I have this bug that the boss
Good. Okay. Yeah, that's pretty much
In charge to filter and triage and everything.
So usually, depending on the section, but if it's critical urgent, and the option and the companies group and the option.
No, this is which one?
Yeah, so
And it's up to anything.
and anything is pretty central. He is aware.
Is it on?
Maybe I know.
Hello. Hello, welcome people. The second talk will be given with David, and David is a software engineer at Google, where he's working on the Kubernetes project primarily on storage and volume subsystem, and his talk will be about provisioning storage and Kubernetes.
Okay. Cool. Thank you for the introduction. So again, yes, I'm David. I work on Kubernetes at Google. Primarily, I'm working in stick storage. So that's the whole volume subsystem. These days, I'm working on this new thing called container storage interface. I'm not talking about it today, but if you're interested to talk about that, I'll be here after the talk as well, and we can discuss that. Also, I'm going to be assuming a little bit of basic Kubernetes knowledge in this talk. I'm not really going to be going over the very basics at all. But even if you don't know Kubernetes that well, this talk is going to be fairly digestible for you as well. Okay, so without further ado, dynamic provisioning in Kubernetes. So, brief agenda of what we're doing today. I'm just going to cover a brief history, some of the Kubernetes volume subsystem details, as well as dynamic provisioning itself. All right. So let's start with a brief history of the storage lifecycle. So this is I'm going to be talking a little bit about what it's like before the cloud, or how it's done in most places today, which is a lot of on-premise environments or just non-cloud environments, and some of the problems that we hope to be able to solve with Kubernetes and the storage subsystem. Okay. So one of the problems that we see with storage in on-premise environments and non-cloud environments is that getting storage tends to be slow and prone to issues. So getting new storage always incorporates cooperation between the cluster admin and the users. So we have to work together to figure out how much storage we need for our workloads, as well as having the cluster admin then go and contact suppliers, provision, actually get the storage from their suppliers, transport it, install it in racks, things like this, right? And all of this takes time. And time is money, time affects your bottom line, okay? There's another small problem with on-premise storage solutions, and that's that you don't really, because it takes so much time between the time that you need the storage and the time to get storage, you run into these pre-provisioning issues. So you don't really know exactly how much storage you're going to need 3 months from now, 6 months from now, 1 year from now. So there's two real options that come out of this, and that's one, you might pre-provision too little storage, and the users of your workloads are actually you're gonna lose trust with them. There might be actual production issues, right? Because you're running out of storage, you might have to scale back or ration your storage, and none of these are good things for your users. The second issue is you could pre-provision too much storage. And so the problem with that is, you're just losing out on margins at that point. You don't really want to buy storage that you're not going to use, right? So we kind of have two sides of the coin here. It's very difficult to get exactly right. One third problem that the Kubernetes storage subsystem hopes to address is the problem of workload portability, right? So a lot of the time your workloads are going to be very dependent on the storage that it's referencing. So it could be dependent on things like the location of the storage, the exact type of your storage, or any other different parameters or properties of your storage that kind of sticks it to this one place, right? It could be inside your code. To move your workload from one area to another, or from one storage solution to another, could take significant development time inside your code, right? And you may be wondering, like, why is this a bad thing? Like, if I'm in my cluster, why do I even care about moving to a different cluster or moving to a different storage solution? Well, your cluster might have the best solution right now, but think about maybe 2 years in the future, 4 years in the future. Maybe your solution isn't the best one anymore, right? Technology is always changing. What if you want to upgrade? Right? You don't want to have to spend all that energy to move your workloads around and change the storage underneath and have all of these problems that come with it. So with those kind of issues, I want to talk a little bit about how Kubernetes aims to solve some of these problems. Okay, and so that involves taking a look at the Kubernetes storage system in general. All right, so let's take a look at the Kubernetes storage system, kind of an overview. So what does the Kubernetes storage system try to do? Right? So the main idea of it is to just make file and block storage available regardless of where your workload is placed. Okay, and so that includes all parts of the life cycle of your volume. That's like binding, provisioning, attaching, detaching, mounting, and unmounting. But in this talk, I'm not really going to go over the implementation details of all of these steps. This is more of just like an overview of like what kinds of things it's doing under the hood to make your storage available. And in that vein, this is just a quick list of all the storage solutions that we currently support in plugins. So as you can see, there's quite a big list. We're actually planning to start moving out of tree, which means that plugins can be third-party. Right now, these are all inside the Kubernetes core GitHub repo, and to actually change them or add more, you have to modify Kubernetes in tree. But container storage interface is that thing that I mentioned earlier. That's moving all of these plugins out of tree. So you can actually write out of tree plugins that will go straight into Kubernetes and make storage available. Okay, so these are the types available. So we want to tackle this problem of workload portability. Okay, so I'll talk a little bit about how we do this in Kubernetes. The way we do it is by introducing a couple new abstractions or layers of indirection. So I want to talk to you a little bit about this API object. This is a first-class Kubernetes API object called a persistent volume. So this is a higher class storage abstraction. It kind of represents the producer in the system, so it represents the storage itself. And it has an independent lifetime of the consumers of the storage. So the consumer would be the persistent volume claim, which I'll talk about in detail a little bit more later. And an important thing to note about these persistent volumes is that they're also dynamically scheduled and managed, just like nodes and pods in Kubernetes as well. Okay, so these are first-class API objects. They're baked right in. So I want to explain persistent volumes a little further. I want to go over an example of what the life cycle of one of these API objects is going to look like. Okay, so you have your cluster admin, right? This could be you. What happens is the cluster admin will provision the persistent volumes. So what this means is creating a bunch of Kubernetes API objects that represent the underlying storage. So an example of the actual spec itself here, we have two different examples of the persistent volumes. There's one for the GCE persistent disk, and you can see it has the basic information about what kind of storage this is, right? So over here it says 10 gigabytes, it's formatted in ext4, and the name of the disk to find it. And you may be more familiar with the NFS type disk, so you can see it has the server and the path to the exports. And what's important to note that these parameters that you're giving to actually represent the storage itself, the underlying storage, these are not like built into Kubernetes. These are just basically key value blobs that are defined by the plugin itself. So if you were to write a plugin for your proprietary storage solution, you can define what kind of parameters you want to take to describe what the storage is that's being represented by this persistent volume. Okay, so now we've provisioned the storage by creating these persistent volume objects. What happens is a user arrives that wants to run a workload. Okay, so the user creates this object, which is also a first-class API object, called the persistent volume claim. Okay, and this represents the consumer in the system. This is representing kind of the user's minimum requirements for their storage. So in this case, all the user has to say when they're making their claim is to say, I want 100 gigabytes of storage. I want it to be accessible via read-write-once access mode, and that's pretty much it, right? To the end user, to someone writing applications like a web app or some sort of end user application, a lot of the time they don't really care what is underlying, right? You don't want to know, I want to connect to the NFS store at 10.5. Whatever. You just want 100 gigabytes of storage. You just want somewhere to put your files. Okay, so once this persistent volume claim is created, there's a binding step. And so what this is it takes the persistent volume claim and it will look through all the available persistent volumes on your system and bind it to the most relevant or the most, basically the best volume or the best persistent volume possible for your claim, right? So what it does, you can see the persistent volume claim binds to a single persistent volume, which represents some sort of underlying disk. Okay, in this example, it's a GCP persistent disk, but you can imagine this as any other thing, like an NFS store or something else. Okay, so after the binding happens, the user will create their pod, which is just the Kubernetes abstraction for a workload. So they create their workload, which references the persistent volume claim, which again references the persistent volume, which references the disk. Okay, so we have a couple layers of interaction here, and we'll see why that's useful in a little bit. Right? This might seem like added complexity for now, but I promise you, it makes sense. It'll make sense soon. Okay, so this is our pod spec. This is the definition of our workload. You don't really need to look at the container stuff. It's just a box that sleeps for a little bit. But the important part here is the persistent volume claim, where we're actually referencing the claim by name. Okay. So note that in my actual workload definition, I'm not saying anything about where the storage is located, how big the storage is, or any of the underlying parameters that you might need to actually get the storage. You just have to reference a claim by name. And so what this kind of looks like is, right, so everything's referencing each other, but the workload doesn't reference the disk directly, which, and that means like, because of these layers of interaction, we're actually able to switch out different parts of this without other parts of the system knowing. So for example, you can use the same workload and the same, and the same persistent volume claim, and actually switch out the persistent volume underneath it. Okay, so we can switch out the persistent volume, and assuming you have some on-premise disk already, and your cluster administrator has made this persistent volume object, you can just switch them out, and your workload will still work, because all your workload was referencing was the persistent volume claim, right? And another benefit of this is that you can actually switch out your workload as well. If you want to remove your workload, put a different one on, and reference the same persistent volume claim by name, what you're going to get is the exact same storage underneath, right? So these volumes and volume claim objects have a completely different life cycle than your workload itself. So you can pull out your workload, put it back in, upgrade your workload, whatever. These other objects will stick around if you want them to, and you can continue referencing them. All right, so this kind of workload portability problem, hopefully we don't have it anymore, right? Our workloads can now move around and just reference different persistent volumes, and these are the things that the cluster administrators pre-provision, so your workload doesn't have to care about those sorts of things at all. All right, but I talked about this problem earlier, right? We kind of still have this, right? I keep talking about the cluster admin has to make these persistent volume objects, so they're still going in and manually, for each disk I have, create a persistent volume object. All the problems from before basically are still there, right? So how do we solve this? Well, in comes dynamic provisioning, which is also GA in Kubernetes. It's just like a normal feature of the storage. Okay. So in order to use dynamic provisioning, we introduced this new API object. So this is also a first-class Kubernetes object. It's called a storage class. And what this is instead of like a persistent volume, which represents one storage disk, the storage class represents an entire, as the name suggests, an entire class of storage. Okay? And so you can see here I have two example storage classes, one that I've called slow, one that I've called fast. And you can see, if you look at the slow one, for example, it uses a provisioner, which is the kubernetes.io/gcupd provisioner. And so these provisioners you can have any of them, like proprietary provisioners. That big list that I showed you before, most of those support provisioning. And then the parameters are similar to the persistent volume. They're just key value blobs that are specified by the provisioner itself. So for each type of volume or each type of storage, you can have different types of parameters. So in this example, GCEPD just takes one parameter called type, and we've specified standard, which is just a normal hard disk drive for the slow storage class, and SSDs for the fast storage class. Okay, so these represent entire classes. Now, very similar to before, when a user comes in and wants to use storage, what they're going to do is create a persistent volume claim. And sorry, I forgot to mention, this is a one-time operation. So when you start up the cluster or something, the cluster admin can create one or many storage classes, right? As many as they want, and name them whatever they want to represent whatever. So the user comes in and makes these persistent volumes, and it looks very similar to the persistent volume claim from before, except now instead of referencing a persistent volume directly, what we're doing is referencing a storage class name. Okay, so this persistent volume directly references the fast storage class. So what this kind of looks like in terms of references again, persistent volume claim references the storage class, which kind of references a provisioner of some sort of storage provider. Right? This could be an on-premise storage provider, this could be GCE, this could be AWS, OpenStack, anything you can think of really. So what happens to provision is that so once these references are made, basically as soon as you create your persistent volume claim in your Kubernetes cluster, what happens is it automatically talks to the storage class and figures out and talks to the plugin for provisioning and figures out how to actually provision a disk. So what it does is it will create a persistent volume for you and attach it to a disk, or sorry, it will reference a disk and then it will bind the persistent volume claim to the persistent volume. So note in this picture that the cluster admin isn't present, and that's not an omission by accident. It's because they don't need to be present for any of these steps, right? They created the storage class, and then they just kind of left. So all of this happens through code. So now the user comes in with their workload, the thing that they actually care about, that they want to run, and it references this persistent volume claim. And if you actually take a close look at this pod or this workload, it's actually exactly the same pod that we were using in the previous example, right? Haven't changed anything. So this is just another example of how we're able to kind of pull up this workload and move it somewhere else with a completely changed the underlying layers, right? We removed this whole PV stuff and replaced it with the storage class that kind of does all these different things, but our workload didn't have to change at all. And from the perspective of our user, nothing has changed, right? They still get the storage that they need, right? So do we still have this problem? Hopefully I've convinced you kind of not. We don't have it anymore because of this dynamic nature of the provisioning, right? We don't have to pre-provision because it doesn't take long to actually get your storage when you need it. And we've removed the time constraints because as soon as the user requests some storage, it starts provisioning and it'll just come back to them as soon as it's ready. Okay, so this is kind of the general workflow, and a cool thing, right, is if you keep the storage class name the same, what you can do is kind of switch out the provisioning, right? So we're on-premise here, we can switch it out. It's AWS, we can switch it out. It's OpenStack, we can switch it out. It's GCP, right? So we can switch out the provider of storage in the background, and as long as we're keeping the storage class name the same, for example, the pod PVC claim, they don't have to change at all. They're completely portable. We can move them from one place to another. The underlying storage changes. The user doesn't care. Okay. So what this kind of allows is sort of. Do you have a question?
If I may.
Yes. Yeah, sure.
You said that actually why we need storage is for example, a developer of a web application to store its files. You doesn't care, of course, where you're going to get this storage from, but once you got it, you store his files, and then you swapped your provider. What happens to his files?
Right, so the question was if a user has some files in their storage provider and then you swap the storage provider, what happens to their files? That's kind of up to the cluster administrator to decide. You don't really just switch storage providers willy-nilly. You can, but of course you will have to do some sort of migration of your data. So this just kind of allows the users to not really care about it because of this layer of indirection. But if you have actual data somewhere, there is a migration cost.
But I don't know, maybe I'm missing something, but then I don't see what's the point of another abstraction layer of claim storage class towards the actual physical storage. For example, if I take NFS or cluster FS or anything there and make that storage available, and if I have to still move the data around, for example, for a new storage, what advantage does this gives me? I just...
We can talk about this afterwards. It seems like kind of a deeper question. All right. So what this kind of allows is sort of a lift and shift sort of thing, but modulo your actual data needing to be migrated, which of course there can be some sort of story there where you actually take your data and move it to the other place, right? That's a whole other problem. But this API, these layers of indirection kind of let you have an agnostic workload. So the benefit here is that the user creates their workload once, they have their app, they have their code, they bundle it, they make all these YAMLs, right? It could be like a whole bunch of different pods and services and things like that. We're able to just move those without changing them very much. Okay. So just a quick demo on how easy could dynamic provisioning be. I'll show you right here. So what we have here is my project in GCP. You can see that I have a Kubernetes cluster already up. And if we take a look at the disks, these are just the the background disks of my cluster. So what I have is the storage classes from the demo, right? So I have a slow and a fast storage class with different types of disks, and I can just create these storage classes. So that just pops those API objects onto my cluster. So now if I control get storage class, you can take a look. They're already there, and it specifies what provisioner they are. So, for example, you can have different types of provisioners as well with different storage classes. Then I have a workload, which is called slow workload. And so I've kind of combined these into one file. Of course, you could have separate files for your claims and your pods. So this claim requests some slow storage, 5 GB of it, and just some other data. It's just this pod that sleeps for a while. Okay? So I want to create this. And all it takes is a couple seconds, but of course, like this is just a dummy pod, right? So it doesn't actually do too much. You can take a look at it. It's just starting. And then if you look at the disks that have been provisioned in my GCP project, you can see that this dynamic Kubernetes dynamic PVC has been created. It's 5 GB and it's already attached to the correct node that the workload was scheduled onto. So all of this just kind of happened in the background. My pod's already up and running. It already has access to this storage, to this standard storage, right? No one really had to come in and intervene. I just had to create my workload, and the storage is there. So I guess this makes a lot more sense for workloads where you might need some storage temporarily, maybe a scratch space to do some work. You can just get that immediately. And as long as your pod is up and running, this storage is also going to hang out with it. Okay? And we can also, if you control, create some fast storage. So let's take a look at that. If we just look at our fast workload, it's exactly the same thing. All I did was change the storage class name to fast. But the pod's the same in everything. So you can see like the pod didn't have to change. I just changed the storage class in the PVC. And now we have another one that's been created that's an SSD, right? Because of that parameter in the storage class. So all I had to do was change a kind of a reference pointer, and it just automatically does this provisioning and mounting and all of that. So inside my pod, so if I want to describe my pods, I mean, it's kind of hard to parse all of this, but basically what it's saying is that these two containers are running, and all the persistent volume claims have been attached. So if you look at the attach-detach controller events, we can see like the attach succeeded, and then it's been mounted and set up and everything. So it's accessible inside your containers already. You can do whatever you want with them. Okay. So a little bit about what's next in Kubernetes storage. So that's kind of what's already been done. We're still working on this thing called the container storage interface, which is bringing all of those plugins that I've been mentioning out of tree. So the third-party plugins can be maintained and versioned separately from Kubernetes itself. We're working on the local provisioner and scheduling. So that's actually taking local disks, so disks that your nodes are actually scheduled on, and kind of taking that storage and divvying it up, so you can get faster storage, closer storage, and all that kind of stuff. And also another push for ephemeral storage allocatables and requests, so that's just reserving some storage space on your node for system components and doing like request limits and requests, limits, and that sort of thing. Okay, and with that, are there any other questions? If you want to contact me, the info is right up there. Feel free to write me down, send me an email. I don't really use Twitter right now, but I plan to start soon.
So there will be a quick break, and then we will be next. We will be back to our next talk on 20 to 3. I think. No, 20 to 4. Sorry. What I meant.
And that's probably the super support. Yeah, there's no support for
I understand. So this evening I'm no problem. If you have like more of like right now I like there is time. We have. I think we have. It's 10 minutes.
show. Yeah, okay. It's just work in progress.
I'm just feeling like that's great. Yeah.
You have to press the orange button. Yeah, on the bottom there's an orange button. Yeah. The red one. Red one, yeah. Red orange.
Hello? Hi. Sorry. So, we had like 20 minutes till the next talk, and I just had a quick project that's basically trying to build Docker images inside Kubernetes cluster, and I happened to redo the Docker in Docker for handling. I had to handle some 0.6 different versions of Docker in the company, and I had to rewrite the Docker in Docker, so at the end I rewrote it with Alpine Linux. And here I have a small project. It's actually just a shell script. It's composed of a shell script and a template, which is reusing. So you had this zubab/qbuild, and it's reusing my version of Docker in Docker, which is based on Alpine Linux. Launching that as a privileged container inside, where, if I don't show the right one, here, launching as a privileged container inside, and it's using a plugin of Kubernetes called MyGitRepo, where you can mount any Git repository inside a pod, inside a container. And if this Git repo has a Docker file in there, it's gonna detect it and try to build it. So I got like one tweet from Jerome Petazzoni 2 weeks ago, and now I got like two new contributors that helped a bit. So the first thing it's gonna do is try to fill up the template, then launch a pod called kubebuild, then watch for this pod to be in a good state, and then tail a log of the build. So this is an example. If I do kubebuild my GitHub repo, then it's gonna template the stuff, launch a pod inside the cluster, wait for the pod. Once the pod is running, it's gonna tail the output of the build process. So the first thing it's gonna do is launch Docker inside the pod. Try to see if the environment repo name is found as environment variable, and then launch Docker build -t with the stuff. Okay, I can also do live demo. So here, I'm gonna hit one bug at some point. I just added the feature that is a random pod, but so it's creating it. At some point, launch the build. Then I hit an error because I'm on a special machine with double layer of UFS, but I tried on another box, it works. So I'm currently looking for people who are interested in doing that. It's a bit like Jenkins, but the hackish way. And I'm working on adding the registry support, like if you have a personal private registry or a Docker Hub account, put your credentials, login password as arguments so that once the image is built, then it's being pushed to a registry. So yeah, that was my 5 minutes project. So if you are interested to contribute, the URL is somewhere here. Somewhere here, so zubab/kubebuild. I got one contribution from India, so and it's written in shell, so it's very affordable to get it to. Yeah, so there's I compiled a bit of list of to do. So yeah, right now it's based on the Git repo Kubernetes plugin. I know that this plugin, I've been told that is very weak because when I specify Git repo that doesn't exist, the container hangs and stuff like this. But at least there is something. So then, the idea is also to support more than HTTPS as a protocol, like SSH, so that it could handle key forwarding inside the cluster. Yeah. So, thanks for your attention. I'm going to leave the microphone for the next speaker.
actually on hand. I don't have a presentation. Yeah, we should be good.
Okay, so you want to match with the PowerPoint or the keynote?
Yeah. I want to see what happens. Sorry. I don't actually, I've never done this way before. Making it up as I go along, so it's not a bad way to see it back. Okay, it's gonna work. For a second, I was like, I kind of want to sweat it. Right? But it's not. Or anyway, it's going to be better toss that attitude. Think about getting sure. It says we're right. We're monsters. They're like you read it if I decided to. You're in the back. Can you read that? Yeah. No. That's what I'm talking about. He's honest. That guy's honest in the back there. He's like, no, man.
He started testing.
Yeah? Bigger? Pretty good? One more? Okay, cool. What happens if I play audio?
That should work. Though preferably not on the stream.
It won't be on the stream.
It will be, but
Great. Great.
Hello. So for the next talk, we have Adam, CTO of Chef, who will give us not really a talk from what I heard, but more of a group discussion slash.
Well, look, we're making it up.
We're making it up, okay.
Yeah.
About Habitat and Kubernetes and how you can use both to manage and deploy your applications.
Yeah, that sounds like a good talk. I'd go to that talk. Ian, who works at Chef and is a delight, had a whole talk, and he was going to give it to you. But when the EU stamps your passport, do you want me to stop talking for a second?
No.
Okay. But when the EU stamps your passport, it's good for 3 months. And he had 2 months left on his passport. And so, luckily, they stopped him at his home airport. And we're like, no. Like, you get on this plane, you can't get into Europe. And so he wound up not being able to come. And then I was on a plane and like got here, and they were like, so, will you give Ian's talk for him? And then Ian was like, here, I'll send you my slides. And so he sent me these slides, and they were cool, and if you want, I can show them to you. But he had it was like this really great history story of like both container shipping, and then sort of how that evolves through the thing, and I got nothing. Like, it was full of like really, what I'm sure were riveting stories about the history of container shipping, but that's not the thing that I could do. So, so I'm making it up, is the TLDR. but I promise I'm entertaining. And I think the hardest part of making it up is that if what happens is I have to stand here and give you a speech for 45 minutes as if I knew what I was talking about in depth, it's going to be a really excruciating 40 minutes for everybody, and you'll wish that I just left the death metal on, which I could totally do, so if that's a thing you prefer. But I think instead what we should do is, how many people here know anything about Habitat at all? Raise your hand if you know anything about Habitat. Okay, so some of you do, that's cool, but most of you don't. How many people here know stuff about Kubernetes? I'm gonna guess it's like the room, because you've been hanging out talking about Kubernetes forever. Okay, so why don't we do this? Why don't we talk a little bit about Habitat, and what Habitat is, and how it works, and why I built it the way that we did. And then let's talk about how that stuff intersects with Kubernetes, because we spent a lot of time thinking about what that integration looks like and how to build it, and why you might think about using something like Habitat even if you're using something like Kubernetes. Does that sound cool? And then I'm gonna use my little iPad here, and I'm gonna draw boxes and squares. And it would be, the closer you get to me, the better this will be, because don't hold questions and stuff to the end. And it's very un-European, I know, but if you want to just shout them out at me, that would be great. Which I know is not your jam. As people, you're much more polite than that. But it'd be cool if you wanted to just be rude for just a minute. Is that cool? Yeah? You want to practice? Okay, let's practice. So when I count to 3, the whole room should shout at me. Yeah? Just yell at me, right? 1, 2, 3. That was that. I mean, come on. You can do better than that. We were just listening to death metal. Okay, it starts here. Down it happens in your chest. You kind of freeze your vocal cords up. Right? Ready? 1, 2, 3. Yeah, there we go. That guy's got this. I don't know about the rest of you. Most of you are fucking silent. This talk's gonna be boring. It's your fucking fault. Okay. Yeah, you heard me swear yesterday, so I don't have to do it again. I don't have any slides. The closer you get, the better it'll be. So let's talk about Habitat. So you heard some of that story that I told the other day. So containers happened. Luke had a good slide in his keynote that was just the Docker, McDocker. And I had a similar experience where every person I talked to was so now that your software is bullshit, your company's dead, and you're all fools, what will you do? What will you do now? And I think for me, there's a really bad way to do product development and a bad way to build companies, I think, which is if your company is only about a piece of software, then the thing you're providing to the people you purport to care about is probably weak too. Do you know what I mean? If the only thing Chef ever did was Chef, that'd be fine, but it's less good, because if our actual job in the world is to help you guys be great at your jobs, then we should be building whatever the software is that we think you need, instead of being so fixated on the success we had last year or 5 years ago. And so the obvious thing to do was put Chef in a container, or use Chef to build containers. And I built all of those things. So we built all those prototypes. And I think the user experience could be summed up as garbage, or hot garbage, maybe would be better. And the reason was that what I thought was great about Docker files was, I swear to God, I'll start talking about Habitat in 2 seconds, and then we'll get to Kubernetes. But let's just do this for a second. So, if I'm writing a Docker file from Ubuntu, and then you're do some shit, and it's essentially a shell script with a couple of little things on it, right? And what's dope about that is that there was very little abstraction really between the thing everybody knew and the thing you were going to pop out the other side, right? And then the next thing that happened that I thought was pretty dope was that you get out of that Docker file, and you're yeah, sure. Sorry. Start Docker. And, you know, this is why I wrote configuration management systems, right? I was supposed to forget all those things. That was the deal. That was also a lie that we told you. Do you remember that lie? Where we were like, hey, you won't ever have to remember how to, I remember this where I was on a panel once. See, I get to ramble. This is my favorite part about making talks on the fly. I was on a panel once with Luke Knies, Theo Schlossnagel. Do you guys know Theo? Theo is like the Michael Jordan of systems administration. If you didn't know that, he's like this. He'll never be as good as Theo. No one ever will. He is so good. Very smart. And we were talking about how hard it was to set up Pixie boot environments, like Pixie booting clusters. And Luke was like, it's not hard, I just run a Puppet recipe that some other guy wrote, and like, everything's cool. And we were like, no, it's not. Like, that's not a thing. Like, it's actually a lot harder to Pixie boot things. And then Theo turned to both of us, and we were in a room about this size, but it was full, which was weird for this panel. So we're talking about Pixie booting, and it was very up our noses. And Theo turns to both of us and goes, you don't need configuration management to do that. Here's the commands. And he just rattles it off on the top of his head. He's like, you install this thing, and then you would put this in this file, and you would write these things. And he did it like 2.5 minutes, and he was just like, dun, 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 Pixie boot done. And I was like, man, that's why we bought, that's why. Like, we need config management because I have no idea what you just said, and I would forget it 2 seconds later. And he was like, well, that's because you guys are done. And I was like, okay, you're right. Anyway, there was a point in time where we told you you could forget about all this plumbing and shit, and that was a lie. You can't. So, but the moment where you did this, you were like, Docker run, all right, fine, because my connection's broken. So look, the thing was, you've all run Docker run before, and you say, I want to run some stuff, and then it happens, and it feels like magic, right? And you'll crawl over broken glass to have that magic throughout the rest of your experience. And it's mostly broken glass after that. Like everything after Docker run was like, whoa, this is not fun at all. But that first Docker run moment was like revelatory, you know? And so I took a vacation, and I spent a couple months aggressively not using Chef. So I used every other thing than Chef to do as much work as I could figure out how to do. I used a lot of Docker, I wrote a lot of Docker files. I fell back in love with shell scripting. That was weird, but I can thank Docker for that, for sure. Is this talk boring yet? You guys over me? Or are you just quiet? You're just quiet, okay. We'll just go with that. And what happened was, the more I played with those tools, the more I started to feel like we were on, like I was a hamster in a hamster wheel. Because we were taking all the things that I knew we were good at, in terms of like we could build a Docker container, I could pack all my stuff in it, I could ship around, I could run services, but it was just another layer of infrastructure again. And that story, one of the stories that Chef and Puppet told you, and others too, was that we were going to give you this like universal abstraction, right? And you're going to be able to use that universal abstraction to run everything, and the whole world would run Puppet and Chef or whatever, and that was it. And you would learn that one thing, and then it was cool. How many people tried to build a universal abstraction with Puppet or Chef? How many of you succeeded? Yeah, none, no people, right? And we're in a kind of similar moment in the container world, where we've all sort of convinced ourselves that there's going to be a universal abstraction, and the universal abstraction is going to be this new infrastructure technology. Like this time, we're going to get the factoring correct. Do you know what I mean? Like this is the moment. And all that was ever wrong was just like a quirk of architecture, you know? And that just didn't feel true to me. And it felt less true the more time I spent on vacation. So the more time I spent on vacation sitting around and thinking about, well, is this finally it, or have we really enabled this like new universal abstraction? And I thought, and the answer was no. And then I thought about, I spend most of my time in companies that aren't my own, or a lot of my time out in the field with customers. And they got a lot of messed up shit. Like there's one of my favorite ones is there's a company that does, they build cars, and their South American division runs one of the largest consumer finance organizations in the world, so they give loans for the cars that they build. And they have thousands of commercial off-the-shelf software apps that run this huge banking operation. And it complies with all sorts of South American banking regulations. but they don't own this, they don't have the source code to the software, right? They told someone what they wanted, and then someone wrote the software to spec and sold it back to them, right? And they have a strategic mandate from the top of the organization to move to containers, because that is the infrastructure future of our life. But their whole business, one of the largest consumer finance in the world, runs on apps they don't own the source code to anymore. And they're written on Windows. And so, like, how are we going to move them to containers? Like, are we going to rewrite 1,000 commercial off-the-shelf software apps to do, like, banking reconciliation laws in Brazil? And, like, to what value? Like, why? Why would we want to do that? And the answer is, because it fucking sucks to run 1,000 COTS apps that, like, you don't own to run a bank. And so, like, if our only way home out of that sucky thing as human beings is to write that software, then we won't care about the business value of it. Like, we'll justify it just because we're miserable. Do you know what I mean? Okay, to my point. So I was thinking about those things, and I was thinking, okay, how would I move those things? How would I take an app like that? And could I get the same, what are the benefits? What are the upsides that I want out of something like Kubernetes or Docker? And what I want are, I want that immutable artifact. I want to be able to build the software. I want to be able to run the thing that I built in every environment wherever I would want to deploy it. I want to not think about provisioning too hard. Like, I want to think about it just enough, but mostly I want that stuff abstracted away from me. I want the application to do things like service discovery and dynamic reconfiguration and binding. I want to be able to update the software safely. So if I want a new release of my application, I want to be able to then roll that out without disruption, ideally. And then a bunch more. And so I was thinking about how would I do that? And how many people in here are software architecture nerds? A couple of you? Domain-driven design, is that a thing you guys are familiar with? So one of the things that they talk about when they talk about domain-driven design, or really object orientation too, in terms of software design, was this idea of an anti-corruption layer. So an anti-corruption layer in software is if you have a service here.
I don't have the screen up yet.
Oh, well, shenanigans. Hang on. There we go. How's that? Okay. Okay, let's do this. All right, so you have this, you have a piece of software here, and let's call it, what should we call it? Somebody pick a name.
Potato.
What'd you say?
Potato?
Potato. I swear to God, I thought you said Jesus. And I was like, wow, this is getting weird. I shouldn't have played death metal. Okay, potato. That's better. I'm much more comfortable writing potato. No, look, it's fine. Anyway. Okay, so we have the software, and it's called Potato. And Potato is particularly poorly behaved, right? Let's assume Potato is just it's bad. It's a big ball of mud. It's the worst piece of software in your world. And you want to be able to change how Potato behaves, but you can't change Potato, right? You're not allowed, you don't want to touch Potato, because Potato is hot garbage, right? And so what you do is you build an anti-corruption layer around Potato. So you have your other piece of software here, apple, because apples are more delicious than potatoes, I guess. And rather than shoving potato into apple and making the ball of mud worse, because if you have a ball of mud and you put something in it, what do you get? More mud, right? So what you do is you build an anti-corruption layer between these two things. And so you put a boundary here where if apple wants to talk to potato, it has to talk through the anti-corruption layer. So you're essentially building like a barrier around a shell, around the bad code, right? And so what I thought was, hey, we keep reinventing the infrastructure thing in an attempt to fix the application layer. What if our applications could just be well behaved? Like, I can't change the inside of the application, but there's actually nothing wrong with the inside of that Brazilian COTS app. It's been running for 20 years. So like, it's great. It's bug-free. It's been bug-free for a decade, right? It just blows to operate. So could we instead put a little shell around it, and build an anti-corruption layer, and talk to that. And if we did, we get consistent behavior out of the applications, right? Because right now, what we're saying is, hey, if you buy all of the constraints of all of the things that make something work in Docker or in Kubernetes or whatever, then you can have nice things. That's literally the story. It's like, great, if you buy into all of this stuff, then you can have stuff you like. And then inevitably, what happens is we want to put the things in there that don't meet those constraints. The talk that was before me was about a storage interface inside of Kubernetes. And I swear to God, I sat through that talk 5 years ago at OpenStack, right? Where they built a storage interface that allowed you to have pluggable storage engines. And like, you could define them in state. And like, we can do that in Kubernetes now too, because you need disk, right? Like, that wasn't a bad talk, for the record. Like, it's not bad kit, I want to see it. But it again is us pushing the infrastructure layer up and saying, hey, like, if you just adapt to everything that I say, then you can have nice things. So this idea of an anti-corruption layer is where Habitat began, because I started to say, okay, well, what are the behaviors of an application? Like, what are the things that applications do? And so let's just run the thought experiment, because this was literally mine. And then we'll get to Kubernetes here in a second. But shout them out. What do you do? What are things applications do?
Run.
They run. What else?
They crash.
They crash. What else?
They exit.
They exit? Like cleanly.
Yeah, exit
Yeah.
0.
Exit. What else?
happens?
Say again, louder.
Logging.
Logging. They log things. Yes, they log. What else do they do?
They core them.
They what?
They core them.
We call them?
Core them. Core them.
What?
It's like crash, it's core them. They
Core dump.
Core dump.
Yeah, we got crashed like 5 times. What else do we do? We talk to databases. Yeah, we talk to other applications, right? What else? Do they deploy?
They fill the memory.
They what? They take memory? Yeah. Yes, they eat memory. They deploy. What else do they do?
Users interact.
Yeah, users interact. They write data.
Network connections, they accept the...
Yeah. What else? They update themselves, yeah, that's right. What else? So here's what's fun. We're gonna run out of steam, and it's right about here. And this is a fun thought experiment for basically any time that you're talking about building automation. Because when you start, it always looks like the problem is intractable. So if I told you we're gonna build an anti-corruption layer that allows us to have a consistent interface to the behavior of all your applications without changing the applications, you tell me that I'm bonkers. You'd be like, nope, that's too big a problem, you'll never get home. But if you just write the list, and you're like, well, what do they do? Like, that's pretty much it.
No,
and like,
they talk to device drivers as well.
sure, they talk to device, I mean, they do a lot, but it's not infinite, right? And so we have this list. And so the thing Habitat did, and does, is I took each of those things and I said, okay, well, what's the right behavior? What do I want as an administrator? And so like, as an operator, when I want to run the application, I want to be able to call the same command to run every application I run, right? I don't want to have to guess. So, you know, a good example there is how many people run CI pipelines that then go to production, so you do like continuous delivery of some kind, right? How many of you have a different pipeline where the details of the pipeline are different for every application you run? Yeah, most of you. How many of you like that status quo? The answer is no one, because it's awful garbage. And so what you would love is to be able to have a single way and just say, every service we have for the whole company, I can just say, have, start, Yorko, service. Right? And if that was just how you started services for the rest of history, then everything else gets simpler, right? Even though under the hood, I don't know what kind of crazy application you have. So like, it could be doing some weird stuff in order to start. But as long as I say, this is how you start, then things get better. And so the other piece you can do there is you can say things like have, start. So you might notice that there's services that are running that are not what I started. And that's because the supervisor is running in the background. So we kind of skipped to some more advanced Habitat stuff. But what happens here is like, the supervisor is running, and I told this supervisor that it's supposed to watch some services, right? And so the side effect is that to start Postgres, Artifactory, Redis, Nginx, all those things are the same way. You just say, start the thing. Now, some of the other things that we do are things like crash. And so if supervisor is running in that little terminal there, if we decide to kill it, oh, that's going to be hard to read. Let me fix my mistake. So we kill Redis. Over on the right, Redis restarted. And it's because the supervisor noticed it died and it came back up, which is basically the behavior you want all the time, right? If your service just crashes for no reason and you declare that its state was supposed to be up, you want it to be up again, right? Kubernetes solves this for you, right? Service crashes, either your container deals with it on the inside or it doesn't. If it doesn't, what are we gonna do? We're just gonna reschedule the pod and run your workload again, right? Because that's the right behavior for applications, right? So that's crashing. Logging you can already see. So logging gets handled by the supervisor by taking whatever you spew to standard out and standard error, and we stick it in the supervisor. So that's how your applications log. You can also log to files if you want to, but it's better to not. And then you can, of course, like stream that log output. You can do all of those things. Other things we said, they talk to other things. So and do service discovery. So the way that works in Habitat is that all the behavior sort of beyond what I just showed you is something that you opt into. So you can say things like have start, or let's say we have an application, we called it potato. No, we're building a new one, we called it apple. So we call it int apple. And let's say that it needed a database. So we could pass find database, and then we could call it postgres.default. And if you saw on the supervisor, you see it right there actually, because Postgres is upset about something. Its health check is failing. It's another thing we do with applications, we check their health. And so that's a built-in thing inside of Habitat. So the health check's failing, so that's good to know. Postgres isn't going to work. But if we wanted to bind our application to Postgres, all we would have to say is we have to declare inside of the Habitat plan, which I can show you in a minute, that a database is necessary. We define what the data is that will allow our application to talk to a database, and then any service can just decide to emit data that works. So essentially what you're doing is building a parametric bind. You're saying, hey, I need an IP address, and I need a password, and I need a few other things to connect to the database, and then some other service can supply that information, and you can bind the two together, right? So you're essentially doing service discovery, right? And then inside of those, and all that's happening outside your application. You have to change your app to get that stuff done. Okay, so what else do applications do? Because we made a list. User interact with them, we sort of showed that stuff. Update and deploy. So, because my network connectivity is not super working in my VM right now, it's hard to show you the update. But the way that that works is very similar. So, by default, you'll never update a service once you start it, because that's the behavior you would expect. But you can decide instead to do so. And if you do, you can basically pass an update strategy. And we can say rolling. So if we were to start the service with an update strategy of rolling, all the instances of our Ghent apple would elect a leader who is going to check for updates. And it would be watching a Habitat repository for new builds. And when those new builds come in, it would decide to update itself. And then each other instance of your service would take turns updating itself, right? And they would just do that automatically because you said so. And so when you start the service, you just pass that option in. And what's cool about this is all those things that we listed off earlier, those are the conversations you have with your peers when you're talking about the behavior you want. You say, what's the safe way to update this pod, right? So can I just blow the whole thing away? Do I do it in rolling pieces? Do I do an A/B deployment? Is it progressive? Do I start with 1 and test it, and then I do 2 and test it, and then I do 4 and test it, and then I do 8 and 16 and 32, and then the whole cluster, right? All of those things just become, they become strategies, right? And you can just pass them to the supervisor, and the supervisor will do the work. The other kind of dynamic stuff you can do is some services have a topology. So a good example there might be leader-follower. So Redis does this. So if we wanted to have Redis clustered together in the leader-follower topology, we can just pass in the leader as the topology for the service we start. And then again, when you have 3 of them or more, they'll let the leader, they'll start the thing, the way that they will go. And we can keep going. Like, there's all sorts of this behavior sort of built inside of Habitat. And in order to get all that sort of magic to work, you write what's called a plan. How am I doing for time? Okay, good. Because I want to actually get to Kubernetes, because I haven't said a word about it, but I swear I'm going. So you write plans. So a good example here is Redis. So this is the Redis plan. Let's make it a little bigger. Not small. And you might recognize this because it's just bash. Remember how I said I fell in love with bash? So this is a plan, and basically it just says, hey, this is Redis. It gets built from an origin. All software in Habitat comes from somewhere. And so in this case, it comes from the core origin, which is the open source project that we all maintain together. You could also build your own version of this with your own origin and just rebuild Redis, and then you would have like Adam's Redis. So one of the other things you do is you're explicit about your dependencies. And we can talk about this later, but this really allows us to do 2 things. So one, the build system that builds the Habitat artifact is smart and understands all of the depths that go into building the software all the way down to glibc. And the side effect of that is we have a build service that we run. It's a hosted one, and you can build your packages there. And it automatically looks at the dependency graph. And so when we ship a new version of glibc, every application that needs it will automatically get rebuilt and a new version published because the dependency changed. So if you think about that day, remember Heartbleed, and you all went to work and you had to patch every server in your world, but then you were like, ooh, did I restart the services? Which version of OpenSSL is in memory, right? Which, it's cool it's updated on disk, but what's in memory? Habitat, you'll never have that problem, because once you release the version that has the patch, that's the version forever, and you can't change because it's actually mutable. What's dope is, only one of us, me, would ever have to make the change to the OpenSSL plan to do that. Once I publish the change to the plan, the build service picks it up, would rebuild OpenSSL, and then it builds a giant graph of all the things that depend on OpenSSL, and then finds the fastest way to traverse it and pushes it all through in parallel. And your builds are done. I talked about those parametric binds. This is another example of that. So this is Redis shows a port, and so this is what we expose it as, and then this is the value internally of what it is. So if you want to use Redis, you can bind to the port number and get it back in addition to the IP address and a few other things. And then to actually build Redis, all you do is call make. So that's the end. It's 21 lines of shell, and all you really have to do is you declare your dependencies. So one cool thing about that is that once we have Habitat artifacts, we can export them into multiple formats. So if we want to build a container, all we do is say, and now what you will get is a minimal Docker container that has Redis, glibc, and the kernel, basically. Like there's no kernel in the Docker container, it's just Redis and glibc. But there's other formats. Tarballs, you could export it to an AMI, you can export it, and soon you'll be able to export it to VM images, right? And then you'll automatically have these tiny things. And again, when you think about those pipelines and the shape of the application problem, that's kind of glorious, because now I can rebuild, if I build my CI system so that every time I publish a new artifact, I also export that artifact into all the formats I want to run it in, then I can guarantee you that no matter whether I'm using Kubernetes or I'm running that COTS app on a VM, in both cases, they're going to get rebuilt on security updates automatically and published, and I can make that pipeline more reliable. And so, so we should switch to Kubernetes. You want to talk about Kubernetes? Yeah? Or do you want to keep in Habitat land?
One remark regarding the previous
Yeah.
slide, it's that the format looks like Gentoo builds. But
yes, it also should look a lot. If you've ever run Arch Linux, it looks like Pac-Man. because I love Arch Linux, and I think that that was the best build system ever made. And I almost just used it, but it wasn't quite right. Reference error 33. Okay, so any other questions? Yeah.
What about something more complex? I mean, you just described Redis, but what if I have something that needs a Redis and I have no idea, Postgres and 5 other things?
Yes, so let me show you.
Is that just basically package debts or?
Well, so if there, so the question was, what if you have more complex things? So yeah, if it's an application dependency, so it's like my application has lots of libraries it depends on, then yes, those are package steps. If it's a runtime dependency, so let's use Habitat itself. So let's go look at the Habitat source code for a second. That's a great place to see some of that complexity. So this is the build service. This is all open source, by the way. So this is the build service over here. And it's a pretty complicated microservice architecture. So there's a lot of very small services that handle pieces of the domain, and then that builds up into the build service. And so the a good example here is the API proxy. What you do is just export the bindings that you care about between that other people want to see. So in Mark Burgess speak, we're exposing a promise, right? That says, if I'm up and running, then I promise that this data is exposed. You can ask for it. And then on the other side, when we go to actually run those applications, you just bind them to each other. So if you have an application that needs 8 runtime services, in this case, there's probably 15 microservices in the build service, right? And when we start them, all we do is tell them the service names and the groups they're binding to. So we would say, hey, the API proxy needs to talk to the API. And so when you start the proxy, what you would say is, start proxy, and you would pass binds, and you would say API. So what you're saying there is, hey, I'm expecting this contract. I need something called API, and you can find, and you, the application, can find API at this service group, right? And so you're really flexible about what you can do at runtime, but you don't declare it when you do it at build time, because you don't know what all the topologies are that might happen over time. So the use case about that is that you want to really be able to ship one artifact the whole time. So what you don't want to have to do is change the artifact in order to run it in multiple environments, right? So an anti-pattern would be, I build 5 containers, one for each of the 5 environments I'm going to run it in, right? And then I ship those 5 containers to 5 different things, and they have 5 different Kubernetes pod definitions and all that junk. Instead, what you want is to just change the options at runtime, and that's what Habitat does. Does that answer your question? Yeah.
To a degree.
I mean, there's a lot of magic behind it, but
what I would basically need is, let's say, I would need a shell script that has 5 hap start commands in the right order in order to get the whole thing out.
Yes, that's right.
Okay.
Yeah, if you wanted to all run it on one box, you would just call hap start and pass the bindings, and you're done. And then that's the exact same thing you do when you're going to run it in production on 1,000 servers. Yeah, what's up?
Does Habitat require root privilege to export to a Docker image, for instance?
You have to speak way louder.
Does Habitat require root privilege to be able to export to Docker image?
Oh, that's a good question. Does Habitat require root privileges to export Docker images? I think the answer is probably not. There's been a bunch of work being done on Habitat and root privileges, so I'm probably a bit of a Luddite in that I've had root every day since I was 15, and so like Habitat required root when it started because I was like, who doesn't have root? Turns out like everybody is the answer. I guess security, go figure. And so there's a bunch of work going on to make that happen. So in particular, OpenShift, I don't know if you've used OpenShift, but OpenShift has a bunch of restrictions about how you build the containers that are kind of, they feel obtuse at first. And we just did a bunch of work to make that stuff work well. So the supervisor itself now no longer requires root privileges. The build service itself does. So like a lot of the tricks we do to build clean room build environments still require root, but we're working on getting rid of those things. And then I don't know if the actual export does or not. It might not. Okay, so one of the designs that we were hoping to get out of Habitat was the idea that if we built this anti-corruption layer, right, would we be able to truly be free from choices of infrastructure, right? Could I give you an abstraction, and that abstraction at the application level would work? If I was right, it would work, whether I was running it on Kubernetes or whether I was running it on bare metal, right? Or any other thing in between. And so, so that's exactly what we did. So we worked with the fine folks at Kimball to build a Kubernetes operator for Habitat. And what the Kubernetes operator does is handle all the plumbing for talking to that anti-corruption layer. So if your services are written using Habitat or built using Habitat and deployed that way, then you can use the operator to get away from all of the bootstrapping and all of the other stuff that you might have to do to get all your services up and running, and they just work inside Kubernetes. One of the really interesting design questions hiding in there is, if I'm a Kubernetes operator, do I want Habitat-enabled Kubernetes, Habitat applications running on Kubernetes to feel like Habitat applications that happen to be using Kubernetes, or do I want it to feel like Kubernetes and not know that it's Habitat, just be like a simpler interface to Kubernetes itself? We took the tack of saying that you probably want it to feel like Kubernetes, and part of the reason for that is that as a person, I just think it's bad form. Like, very rarely do you convince someone that what you've done is cool by saying that the thing they love is not. Does that make sense? So like, it's very unlikely that I'm gonna come in here and convince you that Habitat's dope if my opening line is Kubernetes sucks, why do you need it? Yeah? Right, because Kubernetes doesn't suck, and you know that every day because it's solving your problem, and who am I to tell you that it's not awesome? And so what we did with the operator is basically said, okay, Kubernetes has its own language here. Let's draw it somewhere else. Those are going to get confusing. So you have K8s here, and then you have a bunch of Habitat services. And we built an anti-corruption layer between those two as well. So what we said was, the Habitat operator sits here, and its job is to make it so all of the details, the Habitat-centric details of Habitat-enabled services running in Kubernetes disappear. And so, yes, you might still be using bindings. You might still decide that you could even decide that you want to use Habitat's update strategies instead of Kubernetes. So if you wanted to like deploy containers and you were happy with them living for a long time, but you still wanted immutable deployments, you could do that if you wanted to, right? But it's all opt-in, right? Nothing is, we don't force any of that stuff on you. And honestly, this has been working great. It's about to be in bigger releases, and we'll make a bunch more noise about it. We have it working, we've got a couple of customer sites. None of it's a secret. It's just there's still some rough edges. And I think we're closing in on time, so I should wrap up. Any more questions, or am I done?
You can invite.
What's up?
So there is going to build. Can I skip the build cycle and build the packaging directly?
Can you skip the build cycle and build a Habitat package by hand?
No, the calculation part with the main command.
Oh, yeah, you don't have, I don't care what the software is you stick inside. The thing that you need is a consistent format for the supervisor to do its job. So one of the most common questions we get is, it seems dumb to have built a build system. Like, why did you build a build system? And the answer is, because the life cycle of the application is tightly coupled. Like, we kid ourselves when we say that you build your stuff and then you ship it and then someone else operates it. That's not real. Like, it's actually super tightly coupled together in the life cycle of the application. And so what Habitat cares about is that the runtime format be correct, because there's a bunch of properties that we get from that behavior that allow the supervisor to be way less complex. So one of the reasons that all you have to do to make the plan is build your app is because the final resulting format is one that's easy to export, it's easy to manage, it has properties that's immutable. Like those properties are good properties. If you can't change the software, then all you do is take your software and shove it in the right directory. You know, you're just like, okay, I have a build. I took my binary and I plopped it out over there. If you built it with Habitat, if you could rebuild it, then you get a bunch of benefits. One of them is you could run that binary anywhere that runs Linux without any userland. So as long as you have a modern Linux kernel, like in the last decade, you can just run them, and that's pretty great. If you take an application that was precompiled and just shove it somewhere, then you have a dependency problem that Habitat automatically won't solve for you, can't solve for you, right? You still have a setup step you have to do with the outside world. But that's how we did things like we built Habitat containers of very large, really complicated commercial database software that's built by a 3-letter acronym company that's not very far away from here. Which was hard, but the plan for that wasn't a lot longer than the Redis one in terms of its details. And we definitely didn't recompile it. There was no way they were going to let us do that. More questions? Yeah, maybe.
Do you support static compilation or not?
Yeah, you can do whatever you want.
The glibc typically is not.
Oh, you can swap glibc out. So like glibc is just another software dependency. So if you decide, like for example, we build our own images for Habitat itself, especially for export with Muscle. And like doing that is really literally just like changing a dependency line. So like if this wanted to use Muscle instead of glibc, I don't think this has one, but we would just literally say for, and now you're going to link against Muscle. And that's one of the beautiful things about the build system is that like you can swap out libc, and like that just works and it's fine. And like and everything just moves along. Yeah. Okay. Thanks for listening. Oh, you have more questions? We can take them while you come up here and I'll answer your question.
Should I come over there?
Or do you have one more or what?
No,
We're done. We got to be done. But you can come and talk to me. All right. Thanks.
Can I ask, are these going to be saved somewhere? So this is still live? Yeah. And is it going to be like on YouTube or something?
Yeah, it's on YouTube.
Yeah, okay. Because my colleague wanted to see it, and I have to record my other colleagues' talk yesterday on my phone because, you know, they didn't stream it from there, so I wanted to know if it's... So, okay, that's good. Thank you.
That's not an accident. Back in the room. So like, they work onto that. Yeah, we make it. Or you write it. Yeah. But you do exactly. Oh, my name's Adam. Yeah. Yes.
The guy made all the
Yes. Yeah, Habitat does that sort of on steroids. So like that part of the build step in there, like what it's doing is every time you build software and then dependency results in specific ways. So and then that's right. If you don't code an SSL, the way your application is going to make and make that that's why we built a build system with smart moving backwards, because the user experience that's really well
Yeah, it works. I have your screen over there anyway.
Well, but I'm getting your dashboard over there, and that's
Okay, so for the final talk in the Kubernetes room today, there will be Zdenek, and he will give a talk about running OpenStack on Kubernetes.
Hello. So, I'm going to talk about OpenStack or Kubernetes. So, how many of you are using OpenStack? Good. And how many of you are using Kubernetes? All the better. Fine. So, let's talk about this. About me, my name is Rekanda. I'm working at Cloud Infrastack. We are doing private cloud computing and open source consulting. You can find us on the website, cloudinfrastack.com. So, we'll be running the demo here, which are objectives of the demo. So, we have here the box, which is running the OpenStack and Kubernetes. And the objectives of the demo will be to install Ceph, MariaDB, cluster, which is doing the database for the OpenStack, and install OpenStack core services, which are like Memcache, Rabbit, Libvirt, OpenVSwitch, and Keystone. And also install OpenStack services after them. That's Horizon, Glance, Heat, Neutron, Racender. And we'll try to log in into the new OpenStack report if it will succeed. We'll see. So, let's start with the demo. So basically, I've already prepared some parts of the demo. So before 10 minutes, I deployed Ceph. So we can see like the Ceph is already running. And I also deployed the MariaDB database. So let's see if we can turn it on. Yeah. So it's running it here. So these are the, I think, two basic cornerstones we can begin with. So we can see we have MariaDB deployed, and now we will start with deploying the OpenStack core. So I've scripted it. Okay, so the demo is running, and we can now wait till the core is deployed. We can see that Kubernetes is now deploying new controllers. We can see all the basic services are being deployed as we speak. So let's return to the talk itself. In the meantime, this will get deployed, hopefully. So, you can also watch the demo online. So you can open Wi-Fi network which has SSID OpenStack, and there is a password OpenStack Cloud, and you should be able to visit this URL. It's http with scope.openstack, or sorry, there is a mistake. It's just scope.openstack. So, you know, if you're lucky, try to log in into the Wi-Fi, and you should be able to view the scope as the OpenStack is being deployed. So, the box, which is this running cone, what's this for? It's basically some demo box for doing lab research on OpenStack and Kubernetes. It's good for workshops, teaching, hands-on, of course, presentation. And we are also thinking about putting it into use maybe with some field research or mining industry, whatever. So it's just a piece of hardware which could be used on many interesting tasks. The hardware itself, it's Xeon D processors. So there are like 3 compute nodes, which has the compute and storage. It has 36 GPUs, 190 gigs RAM. There is also control plane from 2 like smaller servers, the Intel NOCs. There is one Wi-Fi, so you can like connect to the Wi-Fi and use it. And there is also one Raspberry Pi which is doing monitoring. So basically, there are the lights, and they will be showing the load of the compute nodes and of the control plane. So now we see the control plane, which is like the weaker hardware, is red. So that means it's loaded as the OpenStack is being deployed. Okay, so let's talk about the OpenStack deployments. So OpenStack on bare metal. It's I think the thing which everybody starts with. There are some pros. It's I think easy for start. We have distributions and installers which exist. What are the contradictions? I think it's expensive because you need multiple bare metal nodes and even more for arch availability. It's also hard to debug, hard to tune because it's all-in-one install, so all the services are on like single node. So it's all like a big black box, and it's also paid to upgrade. So the summary for us, we don't do this. We don't put OpenStack on bare metal. Now, OpenStack on virtual machines. So what are the advantages of running OpenStack in virtual machines? Basically, advantages are that the services are isolated, so it's easy to scale, easy to debug, it's good architecture and convenient install with config management. So we use Puppet for this, and it works very fine. What are the contradictions? It's still expensive because you still need like 30 gigs of RAM for OpenStack control plane, and it's even not in edge available mode. And of course, you have payment upgrades at the same time because you have to do the chorusing and all the other like edge available clusters, and the updates which are done with config management tools are not convenient. You mostly have to do it manually by upgrading and doing the manual work. So the summary is, we do this in production, so our current production OpenStack deployments are deployed in the virtual machines. And about configuring it, so we use Puppet for configuring OpenStack on virtual machines. It's our production platform. It's also our favorite config management tool because it nicely plugs with the rest of the architecture. And also the Puppet OpenStack modules are very mature, so it's convenient to work with them. It's stable, it's reliable, simple, easy to use. You still have to do your homework because you need to take the Puppet modules and assemble them and make them deploy OpenStack as you like it. So you still have to do some work, but it's convenient. So let's see how our install is going in the meantime. Yeah, so it seems we have completed already the step number 2. All the OpenStack core services are deployed. So let's see how it looks. So we have the services. So we see Memcached, Keystone, RabbitMQ, and MariaDB are all deployed. So I think we can go to the next step and to deploy the OpenStack services itself. Okay, so The services are being installed now. It looks much more interesting than before. I will try to little rearrange it so we can see. So basically, this is how the services look. We have also the controllers and many more pods which are being deployed. So let's wait till this is being completed and move on with the presentation. So now the OpenStack containers. I'm not saying Kubernetes here, just containers, because it's not the same. Pros, it's very lightweight. What we observed when you compare deployment on virtual machines, you consume, I think, half of the memory which you need, and it's also in actually available mode. So it's pretty good. You save maybe 2/3 of the memory. So this is very nice. Edge availability. It's and updates are built in. With Kubernetes, you don't have to solve the corrosive and clusters and stuff like this, which you have to do with virtual machines. So this is very big advantage, and it's, I think, most promising of all ways how to deploy the OpenStack. What are the contradictions? It's still very complex. Even the Kubernetes and the architecture itself, it's hard to get it together. Also, it's very opinionated deployment, so you have to really make work on it and adapt it for your environment, because out of the box, I think it's not suitable. So the summary we do in this development, and we want to do this in production, because I think it's the best way. So how about OpenStack and Kubernetes? We have multiple flavors how you can deploy OpenStack and Kubernetes. I think the first who started was Cola and Stackanetes, and now the new contender is the OpenStack Helm. Vendors do have their own incarnations. I think Kubernetes has its own build system also on Kubernetes, and Canonical, they also have some containerized way how to deploy the OpenStack. But we have chosen the OpenStack Helm. It's now official project with OpenStack. It is good community. You can find it on GitHub. Let's talk about the Helm part. So it's the open source project by Days, and basically it streamlines installation and management of Kubernetes applications. So you can imagine it like apt, Yum, Homebrew for Kubernetes. I think it's a must-have for complex software deployment like OpenStack, and also a part of many other things. It includes flexible templating engine in Go and YAML configuration data, so it's very convenient to use it for things like deploying the OpenStack. So OpenStack Helm project. It was created by folks in AT&T. I've first observed this on OpenStack conference in Austin. Basically, their goal was to provide reproducible, all containerized and easy upgradable platform for managing dozens of production and development OpenStack clouds. They have really a lot of them, so it's a lot of work to update them and so on. So it was like a logical step. Now it's under OpenStack Foundation. There is the GitHub. It was already mentioned about the OpenStack Helm architecture. So deployments are managed by Helm, as I already said. Components are using hybrid images from Docker Hub. So there's multiple parts like Ceph, which is from the Ceph vaults, and they are basically collecting all the containers and putting them work together to create the OpenStack deployment. As I said, it's 100% containerized, and it features rolling updates, and it's relatively easy to install. OpenStack Helm basics. So it supports multiple ways of deployment. There is all-in-one deployment for, I would say, development, and you can do also multi-node bare metal install, which is exactly this case now. It requires fresh Kubernetes cluster, which is set up by CubeAddon tool. And then the default choice of network overlay is Calico. We also use Calico because Calico nicely integrates with OpenStack itself. So you can have this like BGP talk and work with the Neutron, and you can also have the BGP and Calico talk to your TOR switches. So I think it's very, very good technology for like networking overlay, and it's compatible across the OpenStack and Kubernetes itself together. So it's very advantage. You can have all these networking like in one package. So that's the Calico, and the storage is provided by Ceph. That has become already a standard for OpenStack these days, so no wonder it's here. So about the multi-node install, which we have deployed here, we have here one Kubernetes controller, we have one network node, and 3 computer and storage nodes. The Helm supports node labeling, so you can easily like tag your nodes and decide like where you want to have all your roles deployed. So it's easy to spread them. And installation is like multi-part, so all parts are deployed by Helm. But they must be deployed in order, and you have to make sure that all the dependent services are ready before the next steps. So it's not like, you know, push one button and deploy OpenStack, but you have to do like multiple steps as we are doing here. What are challenges with Helm? So it still provides open-ended deployment of OpenStack. So I would say it's not suitable for production use out of the box, because everybody uses OpenStack his own way. So we have to make it work for you. So as I said, we have to rearrange the architecture and combine our containerized and non-containerized components together. For example, the Ceph, we for sure don't want to run Ceph in containers, because we have like, you know, big bare metal nodes which have the SSDs and stuff like this. So for that, I think it's not suitable to have it in the containers. So we have to like, you know, change the approach and rearrange the architecture. And it also demands relatively high investment into the work which you have to do like to really make it work for you. And of course there are risks included with new technologies which you have to cope with. So the conclusion. OpenStack on Kubernetes. I think it's definitely the best way to run OpenStack. As I said, it addresses multiple problems. It has got a scalability, edge availability built in. You have consistent upgrades. And we are moving towards this regards a production platform. So I think it has a great future as a new way how to deploy the OpenStack and make it work better for you. So that was basically this, and let's see what happened here. So, okay, I would say we are all set up. So as we can see, there is the deployment which is completed. We have a lot of services which are deployed, and I can maybe maximize it a little. Okay. We can make it maybe more transparent. Yeah, so basically here is all the deployment scheme. So this is how the OpenStack looks when it's deployed with container technology. We can see the controllers here, we can see the pods. So that's basically it. I think the deployment is completed successfully. And let's see if we can open the dashboard. Okay. It's all ready to go. So Okay, so the horizon should be working in node port mode on this address. So let's see. Oh, it's here. Cool. Yep, so this is our new OpenStack deployed right from scratch by Kubernetes. So we can see like it's working. I'm not promising it's 100% working everything, but basically you see we have already our 3 hypervisors registered, which are the nodes, and I would say the OpenStack is ready to go. So I think we have succeeded in deploying OpenStack with Kubernetes today. So thank you for your attention, and do you have any questions?
No questions? Okay, thank you, Zdenek.
So for people still hanging around in Ghent tonight, there's a meetup, a Kubernetes meetup, that starts around 6:30, and it will be in the same room here. So if you want to hear more about Kubernetes, join us at 6:30.